board. Lecture has started. Come on board. Hello. Yes, come on. Very good. Daniel, God bless you for being the first person to be here. Can you hear me well? Can you hear me clearly? Daniel, please, I want your response. Can you hear me? And can you see the board clearly? Please, let's come on board, please. Let's come on board. Let's come on board. It is time. Let's come on board. Yes, your responses. Can you hear me? Yes. Can you hear me? Let me hear. Yes. Can you hear me? Yes. Can you see the board too? Can you see the board too? Beautiful. Beautiful. So let's start. Let's get started. Very good. Very good. In the course of this lecture, later we'll use a microphone later. You can't see the board. What do you mean by you can't see the board? Can you see the board? Hello, can you see the board? Okay. So let's start. This afternoon, we are going to talk about matrices. I said we're going to talk about matrices. By the grace of God, we are going to finish everything on that matrix today. Yes, I believe in God. I hope you can hear me clearly because the microphone is being charged. Very good. It's being charged. So I didn't know that I didn't charge the microphone. Now we start with the definition of a matrix. Let's start with the definition of a matrix. What is a matrix? That's the first thing we're going to do now. What is a matrix? You know, a matrix is a set of numbers. Let me write that. A matrix is a set of real or complex numbers. It could be real. It could be what? It could be complex numbers. I hope you can see the board. Oh, very beautiful. Real or complex numbers. That is, or elements. Arrange in columns and rows. Arrange in rows and columns. To form a rectangular array. So that's the definition of a matrix. Okay, that's the definition of what? A matrix. So now, having defined matrices, or matrix rather, matrix is singular, matrices is plural. Now, let's look at what we mean by the rows and columns of a matrix. Okay, the rows and columns of a matrix. We observe that. Having rows and columns of matrices shall give the what? The order of the matrices. Now, if a matrix has, let's say, the number of rows and columns define the order of the matrix. Okay, order of the matrix. For example, okay, let me write this clearly if you can't see this. So let me clean this. So be able to use the word effectively well. Okay, let's be doing it like this so that we're able to see this, what I'm writing. So the numbers of rows and columns of a matrix define the order of the matrix. How? What do I mean by this? Beautiful. So a matrix with m rows and n columns is called an m by n matrix. Let's clean this now. An m by n matrix. Okay? So now we always mention the rows before we mention what? The column in a matrix. The row comes first when you are listing or when you are mentioning the column of a matrix as with regard to the what? To the rows. So we first of all mention the rows before we mention what? Before we mention the column. So a matrix is usually presented by writing it for arrays with the what? With the brackets. That is, a matrix. We want to present a matrix. You always what? You always write it in bracket. Okay. Now let me quickly give you this. Let's say, for example, we have 5, 4, 3. Okay, 7, 2, 8, Let's say 5, 4, 3, 7, 2, 8. Now, this 5, 4, 3, 7, 2, 8 are elements of the matrix. Okay, these are elements of the matrix. And this matrix is called what? Let's check. I've told you that, matrices are arranged in rows and columns to form a rectangular array. So this is an array now. We have an array. We have 5, 4, 3, 7, 2, 8. Now, what's the name of this matrix? What is the order of this matrix? Let's check. See, the rows of a matrix is always horizontal, while the others is always what? Is always vertical. So let's look at this. How many rows does this matrix have? This 1, 2. So this is 2 by, because we have 2 rows. The row is always horizontal, like I told you, while the column is always vertical. So we have 2 rows here now. The first row, the second row. Now the column. Let's count like this. 1, 2, 3. So this is what we call what? 2 by 3 matrix. We call this what? 2 by what? 2 by 3 matrix. We call this one what? 2 by 3 matrix. Now let me give another example and see what we are going to call that. Let's look at another example of a matrix. Okay. Now, note. Suppose we have a matrix with this 1 minus 1, 0, 3. Okay. 2, 4, 6, 8. 7, 3, 2, 1. And okay, let's stop here. So let's stop here. Now, yes, this is another matrix. This is a rectangular array of rows and columns. Let's try this. What's the name of this matrix? What's the order? To get the order of this matrix, let's count the row first before we count what? The column. Okay? Now, how many rows? 1, 2, 3. So we have what? 3 by, that's the number of rows, is 3. Now, column. 1, 2, 3, 4. So this is what we call what? 3 by 4 matrix. We call this what? 3 by 4 matrix. Okay? Now, that is that about that. I hope that is clear. Okay? If that is clear, please say yes in your comments section. If that is clear, please say yes in your comments section. Okay? Say yes in your comments section. If that is clear to you, say yes. Let me hear you say yes. Right? See, let me see you say yes. Beautiful. God bless you. God bless you. Now, let's now split what we mean by, row matrix and what? And what we mean by column matrix. Let me give you an example. For row matrix, this is a very good example of a row matrix. This is it. Let's say 7, 3, 4, 2. This is an example of a row matrix. Why do we call it a row matrix? As you can see, it only has a row. It doesn't have a column. You will think, but no. You can see that we have only one row here. It doesn't have what? It doesn't have a column. We call this what? A row matrix. And what is the order of this matrix? The order of this matrix is the name of this matrix. Okay? Now let's do. 1 is the row, 1 by the column, 1, 2, 3, 4. You might be saying that, but you said there is no column here for this matrix. Beautiful. What we simply mean is that for it to have a column, it will not have only one row. So it will have columns, in addition to this. So this is called what? The order of this matrix is called what? 1 by 4, because we have one row and we have 4 columns. That's an example of a row matrix. Let's look at an example of a column matrix. The column matrix now, as you can see, will be this. I want to write this in the form of column matrix. 7, 3, 4, 2. This is a very good example of a what? A column matrix. Why do we call it a column matrix? You will see that it has only one column. The rows are not arranged there, but we can see, you can see say that for it to have a row now, we said row by what? We said row by column. We always mention row first before you mention column. Take note of that. Okay, so if you want to consider the row here, we have 1, 2, 3. 1, 2, 3, 4. So this will be 4 by. Then how many column does it have? It has only one column. So this is what we call 4 by 1 matrix. I hope you understand this. Good. If you understand this, say yes. Say yes. Say yes. Type yes. Let me hear you. Let me see you typing yes, please. If you understand this one, say yes. So we have examined and defined the row and column of a matrix. Okay. So now the next thing is let's look at some other things about this matrix. Without wasting our time, let's talk about the conformation of matrices quickly. Now, if a matrix, I'm not talking about conformation of matrices. We are still going to discuss this later. Let me quickly chip this one in. Suppose you have you are asked to multiply two matrices, and one has 2 by 3, and the other one's what? The one was 3 by 4, or 3 by 2. 3 by 2. Let me say that. So if you have this kind of matrices, you are asked to multiply this by this. It is very easy. You know why? Why is it easy? Good. You know, to multiply this kind of matrices, since the first one has 2 by 3 matrix, and the second one has 3 by 2. You can see that the number of elements in the column here is 3, while the number of elements in the row here is 3. Since 3 appears consecutively here, 3 here. So the result of the multiplication will be what? 2 by 2 matrix. Okay. Now let me give me another example. Suppose we have this. Let's say this 3 by 2 matrix multiplied by what? Multiplied by 3 by 2 matrix, or 3 by, let's say, yes, I can use 3 by 4, anything. Let's say 3 by 4. Now, this matrix does not conform to multiplication. Why? You can see that the column here is 2, the row here is 3. 2 and 3 are not the same thing. So this is not what? It's not possible, not conformable. Not conformable. You can't multiply this kind of thing. Because the last column here, with respect to the first row, they are not the same thing. For the first one, they are the same thing. So we call that what? Conformable matrices. I hope you are getting it. You are getting it. And you can hear me well. Beautiful, beautiful, beautiful. So let's go to another thing. Let's go to another thing about these matrices. Let's go to another thing about these matrices. Okay. Now let's discuss what we call double suffix notation. We call this one double suffix notation. Now, what do we mean by double suffix notation? Double suffix notation in matrices. Okay. Now, when we say double suffix notation, what are we trying to say? We are trying to say that each element in a matrix has its own particular, element, which has no particular location, rather, which can be defined by a systematic or system of double suffixes, and it's has an element in the row and the column. Let me quickly show you so that we don't really waste our time on this. Now let's look at this very good example. Let's say we have A11, we have A12, A13, A14. Okay. Now for that matrix. Now here we have A21, A22, A23, A24. Okay. Now we have here A31, A32, A33, and A34. Now look at this. This is what we call double suffix notation. We can use double suffix notation in matrices to represent the matrix elements. Now we have A11. What does it mean? You see, when you see A11, when you see A11, what do we understand by A11? Let me write this here. A11. Now A11 simply means the first row and the first column. Okay, the first row and the first column. You can see that. If you know this particular matrix, let's go first of all locate this. Let's mention the name of this matrix. Now, what do we call this matrix? This matrix, what is the order of this matrix? The order of this matrix, like I told you, let's count it. 1 for the row, 2 and 3. So we have 3 because it has 3 rows now. 1, 2, 3. It has 3 rows. Now, how many columns does it have? 1, 2, 3, 4. So it has what? It is 3 by 4 matrix. So what we now mean by double suffix notation here, you can see that this A11, we have two elements there. It's telling us the location, the position of the element of the matrix. It's saying that we have this element A11 is in the first row, as you can see, and first column, as you can see. Now this one A12 means, the element A12 is in first column because I told you that you start with column. Sorry, it's the first row and second column. Sorry about that. That's a slip of tongue. Now you always start with the row before you mention column. It should be what? Row first before you mention column. So let's look at this now. A12. It means the first element, this particular A12 is in the first row. You can see. Why is in the second column? You can see. Because if you count the column 1, 2 is there. Now A13 means the element here, the position of the element here is in the first row, as you can see, and the third column. A14 means the element is in the first row, but the fourth column. So that is that about that. Now, let's illustrate this. Now, let's go about this now. We are going to finish this matrix today. Yes, we see. We are finishing everything today by the grace of God. Now, I want to give us an illustration. Let me use this particular example to illustrate. Now, illustrate using the double suffixes notation, using the double suffix notation, okay, in the matrix, using the double suffix notation in the matrix, okay. Now let me write the matrix out. 6 minus 5, 1 minus 3, okay. 2 minus 4 and 8 and 3, okay. 4 minus 7 minus 6 and 5, all right. Minus 2, 9, 7 and what? And minus 1. Now, this is an example that is talking about the double suffix notation. Now, the question says determine the location of 1, the element 3, 2, the element minus 1, and 3, the element 9. Yes, I hope you can even do this as an exercise. Can you do this as an exercise? Can you do this? If you can do this one, say yes. Can you do this now with the explanation I've given you so far? Can you try this? Can you try this? Can you try this? Let me hear you. Let me you say yes. Oh, beautiful. These students are brilliant. Now, I want you to do this, okay, as an exercise after this class. Okay. Now you now send it to my what? You now send it to my email, the one I've given you. But if you don't have the copy of the email, I'll give you the email you will send it to. This is the first assignment or the first exercise I will consider for marking. Okay. So let's continue because of our time. Let's continue. Now, this double suffix notation, do you know that we can represent double suffix notation by what? Using Aij. You can use this to represent, this is a representation of matrix. This is what? Is a representation of what? Matrix. It means that we have a matrix with element I being the row and element J in the column. Or we can use letters. You can use letters to represent like A, B, and so on. Okay, to represent a matrix. Okay. Now from here we move to what we call equal matrices. Okay. When our matrix is said to be equal, I wouldn't want to really write anything notes on the board. I will only read it out to you so that we will not waste our precious time. Okay. Now, equal matrices. When our matrices is said to be equal, matrices are said to be equal if their corresponding elements are equal. That's all. That's just the definition. Two matrices A and B, say A and B, are said to be what? Equal if their corresponding elements are equal. Let me give us an example. Now I can say that this matrix, if let's say, let me give you this a very good example. A, B, C, D, E, F, G, H, I. If this matrix is equal to 5 minus 7, 3, 2, 0, 1, 1, 8, 5, or 4. Okay. Now, these two matrices are said to be equal if the corresponding elements in the matrices are equal. What do we mean? If A is equal to 5, and B is equal to minus 7, and C is equal to 3, D is equal to 2, E is equal to 0, F is equal to 1, G is equal to 1, H is equal to 8, and I is equal to 4. So if this happens, it means that the two matrices are equal. Okay, I hope that is noted. All right. If that is noted, let's move on. Now let's now go to addition and subtraction of matrices. I hope I'm not too fast. If I'm too fast, please let me know, please. Addition and subtraction of matrices. Very easy. You will see the beauty of matrices here now. Addition. The break that I had a call that's actually disrupted something. Okay, so now let's for example, let me give an example. The matrix 4, 2, 3, 5, 6. If we ask to add it to another matrix 1, 8, 9, 3, 5, 4. Suppose we want to add these matrices together. So just add the corresponding element. Please, are we back? Are we back? Are we together? Oh, sorry. Oh, sorry. I will slow down now. I will slow down. Okay, sorry. Now I will slow down. We have two matrices here. This is a matrix, this is another matrix. We are asked to add them together. Oh yeah, you are adding corresponding matrices. Say 4 plus 1, 4 plus 1, 2 plus 8, 2 plus 8, 3 plus 9, 3 plus 9. Okay, I hope that is clear. You can see that. Beautiful. So now 5 plus 3, 5 plus 3, 7 plus 5, 7 plus 5, 6 plus 4, 6 plus 4. Okay, now the result of this will be what? The result of this is what? 5, 10, and 12. This is 8, 12, and 10. So that's the result of that addition. That's the result of that addition. So if suppose we are asked to subtract, let's say it's now subtraction. Again, I can clean this. Okay, let's say it is now subtraction. Sorry about being too fast. Please. Sorry. So let's say it's now subtraction. Okay. Suppose we now want to subtract this matrix from this. So just like you have done for addition, it will be 4 minus 1, 4 minus 1, 2 minus 8, 2 minus 8, 3 minus 9, 3 minus 9. Okay. Now 5 minus 3, 5 minus 3, 7 minus 5, 7 minus 5, and 6 minus 4, 6 minus 4. So what will be the result now? Oh yeah, 4 minus 1 is 3, 2 minus 8 is what? Minus 6, 3 minus 9 is also what? Minus 6. Okay, 5 minus 3 is 2, 7 minus 5 is 2, and 6 minus 4 is also 2. It is funny. So that is the result of the subtraction. That's the result of the subtraction. Okay, are we still there? Please try to be there, please. Okay, good. Now let's move on. I have another practice exercise for you on that, which I will give to you later. Now let's go to multiplication of matrices. Multiplication of what? Matrices. We can use scalar multiplication. We can also use what do you call it? Multiplication by another matrix. That is matrix multiplication, scalar one. So let's look at multiplication of matrices or matrices. Multiplication of matrices. Multiplication of matrices. Okay. Now, like I said, you can have a scalar multiplication of product. You have scalar multiplication of matrices and product multiplication of matrices. Okay. Now, let's say that for scalar, for example, 4 multiplied by the matrix 3, 2, 5, and 6, 1, 7. Now, this is what we call a scalar multiplication. Because why? Because we are using only one element to multiply the matrix. And the only element that we have here is 4. So now you can say 4 times 3. 4 times 3. 4 times 2. 4 times 2. 4 times 5. 4 times 5. 6. 4 times 1. 4 times 1. 4 times 7. 4 times 7. Okay? Now, that is how to do scalar multiplication. Okay, I hope you can see the board clearly. Please type yes if you can see the board. Beautiful. Type yes. Let me see you saying yes. Yes. If you can see the board clearly and you can hear me, please say yes. Okay. Say yes. Oh, beautiful, beautiful. These students are brilliant and serious. I love you all. Love you. Now, 4 times 3 is 12. 4 times 2 is 8. 4 times 5 is 20. 4 times 6 is 24. 4 times 1 is 4. And 4 times 7 is 28. So this is what we call what? Scalar matrices. I mean scalar multiplication in matrices. Okay? Now let's look at matrix product. Matrix product. That one is quite different from scalar multiplication. Matrix product. Matrix product. Now, let me give us an example. For example, let me write this as matrix product. Matrix product. Let me use small letter. I mean small singular. Matrix product. That is product of matrices. It's the same thing. I say matrix product. Now, for example, if A is equal to, if matrix A is equal to 1, 5, 2, 7, 3, 4, and B is a matrix that has the following elements: 8, 4, 3, 1, 2, 5, 8, 6. 2, 5, 8, 6. I hope you can see what I wrote there. Can you see that? Can you see? Can you see that? Can you see? If you can see what I wrote now, please say yes. Right? Type yes. Oh, you hear me? God bless you. God bless you. God bless you. Now, matrix AB now. AB. That is, we are multiplying this matrix by this. We first of all have to check whether it is conformable, whether the multiplication can go. If it cannot go, don't disturb yourself. Let's check. How do we check this? Good. Now, this is how you check it. What's the order of this matrix? The order of this matrix, I told you, when you want to mention matrices, the order of matrices, you have to start with the row before you go to column. Please take note of that. Row before column. How many rows does matrix A have? 1, 2, 3. So matrix has 3 rows. Let's multiply it by how many columns? 1, 2. It has only 2 columns. You can see vertical counting. The columns are in vertical form, while the rows are in horizontal form. Now we want to check. Let's check this one. How many rows does it have? 1, 2. It has 2 rows multiplied by column. 1, 2, 3, 4. 4 columns. Now you can see that. Like I told you the other time, the column here is equal to the row here. Since they are equal, this is conformable. So what are you left with? 3 by 4. The result will give you what? 3 by 4 matrix. That's what the result will give you. 3 by 4 what? Matrix. Okay? I hope you understand. I hope you understand. If you understand what I'm doing here, please type yes. If you understand what I'm doing here or what I've just done, type yes, type yes, type yes. Okay? Type yes. Oh, beautiful. You can see the board clearly. You can hear me clearly. And you understand what I'm doing. Beautiful, beautiful. Now, let's move on. Let's move on. Since these 2 matrices are conformable to multiplication, that means we can carry out the multiplication. Let's try. Now, please, in this case now, you have to be what? We have to be very attentive so that you understand this, because matrix multiplication seems to be somehow technical. But I will explain the secret to you. Now, I will give you the secret. If you want to multiply matrix A by matrix B, you know it's A times B, not B, A. You know, what we're going to look for is A, B. Okay? We are looking for what? A, B. So matrix A multiplied by matrix B. That's our target. Now, you pick this. You start with 1, multiplied by 8. Say 1 times 8. I say 1 times 8. Plus, you must add something. And again, in the first row, we have 1 and 5. In the first row, we have 8, 4, 3, 1. So now 1 times 8. Now say plus 5 times 2. Yes. That would be in the first position. Wow, you are confused. Well, come on, don't worry. Oh, yeah. Pick 1. Multiply by 8. Then add the result to 5 times. After picking 1, you still have 5 on that row. Now multiply it by the last element in this column. Yes. Oh yeah. 1 times 8 multiplied by 5 times 2. Sorry, add the result. 1 times 8 plus 5 times 2. That is how you do that. Now for the second column now, okay, we are still using one. We start with 1 again. Oh yeah. 1 times 4. 1 times 4 plus, I say 1 times 4. It will remain what? 5 here. 5 times 5. 5 times 5. Yes. Okay, we have settled for the second location. Now again for the third location, 1 times this one again, 1 times 3, okay, plus 5 times what? What is under 3? 8. 5 times 8. Okay, the next one, I say 1 times 3 plus 5 times 8. Beautiful. Next one, 1 times 1, 1 times 1 plus 5 times 5 times 6. Please, I hope you are following. I hope you are following. If you are mixing out, please let me know first before we move further. Okay, now we are done with 1 and 5. You can see we are done with the 2 of them. Yes. Now let's pick 2. Let's pick 2 because second row. We are 2. 2 times the second row now 8. 2 times 8 plus, what do we have left after picking 2? We have 7. 7 times 2. That's the logic, please. That's the logic. Please, it's very understandable. Again, I pick 2 because we have done with 1 and 5. Now we are dealing with 2 and 7. 2 times what? 8 plus 7 times 2. Now the next one, 2 times 4. 2 times 4 plus, I said 2 times 4, then plus 7, still under that in that row by 5. 7 times 5. Yes. Now, the third position, 2 again, 2 times 4, times 3, plus, I say 2 times 3. 3 is in the third column. Good. Then, it remains 8 under that 3. 7 times 8. Then the last column here, the last location, for the last location, 2 times 1 plus 7 times 6. How we can see what I'm writing? Can we see what I'm writing? Can we see what I'm writing? Wow. Thank you. You don't understand. Abba. What? Okay, let me go back again. If you don't, because you must understand. When you are multiplying 2 matrices together, we want to multiply matrix A by B. So the first element in A is 1. You pick 1 times the first element in B. 1 times 8. Now plus the next element in that one, on that row, you take it and multiply by the last element in that column. You pick 8 from the column here. So say 1 times what? 1 times 8 multiplied by 5 times. The multiplication is like this. Go like this. Exactly. If you can, that's the style. That's the style. Okay. 1 times 8 plus 5 times 2. That is done. The next is 4 here on that column or on that row. 1 times 4 plus 5 times 5. That's what we have here. Okay. Now we have done with this column. Let's go to 3 and 8. 1 times 3 plus 5 times 8. You can see that is done. Then the last one is 1 here. 1 times 1 plus 5 times 6. You can see here it's here. I hope that is clear. Now for the next column, next row here, 2 and 7. 2 times 8 plus 7 times 2. That's what we have here. Okay, again now, 2 times 8 plus 7 times 2. That's it. Now for column 2, where we have 4 and 5. 2 times 4, you can see, plus 7 times 5, you can see. Okay, now also here, we are on the third column now, 3 and 8. 2 times 3 plus 7 times 8. You can see, this is what we have here. The last column, we have 1 and 6. 2 times 1 plus 7 times 6. Now we are done with 1 and 5, 2 and 7. Let's not do it 3 and 4. Okay? Please, are we getting it? Oh, beautiful. Now 3 times 8. 3 times 8 plus, I'll pick 3 and 8 now. Remain 4 and 2. 4 times 2. Okay? Now the next, 3 times 4 plus 4 times what? 5, because 5 is under 4 there. The next, 3 times 3 plus 4 times 8. Okay, the next, 3 times 1 plus 4 times 6. Yes. So that is how to carry out that multiplication. I hope that is clear now. The guy that said he doesn't understand, I hope that is clear now. I hope that is clear now. I hope you can. Okay, beautiful. So now, what is the result? What is the result of this? If you carry, you can do this yourself. So I wouldn't want to be writing the answers out. I mean, I wouldn't want to go by the steps one by one, because these are simple addition and multiplication. So the result, if you add everything together, you are going to have AB is equal to, you are going to get this, 18, 29, 43, 31. Then we have 30. You can check later. 43, 62, and 44. Then we have 32, 32, 41, 27. So you get this. This is the result. Okay? So let's move on. Let's move on. Now, I hope that is understood. Say yes, type yes, type yes, type yes. If you can understand that, type yes. Type yes, type yes. Oh, good. Thank you. Thank you very much. Thank you very much. Thank you very much. Thank you. Okay, very good. Now let's continue. Now let's continue. Let's continue. Now we want to illustrate with some examples, and okay, suppose that let's look at this. Given that, just another example. Given that A, that this matrix A is this. What's the order of this matrix? Please type the order there. I want to see. Oh yeah. Before I continue. Oh yeah. If you have been following me, what is the order of this matrix? Oh yeah. Type it on your this thing, on your comment section now. What is the order of that matrix? I want to see whether you are actually following. This is matrix A, which is 4, 7, 5, 2. When I ask you the order, it means the row and column, the line. Oh yeah, what is the order? What is the order? 2 by 2. Good, beautiful. 2 by 2. Oh, very good. God bless you. God bless you. 2 by 2. Wow. I'm glad. This is 2 by 2 matrix. That's what? 2 rows and 2 columns. And we call this square matrix. When we get there later. When we say a matrix is a square matrix, it means that the number of elements in the row is equal to the number of elements in the column. So now, if you are given this type of matrices, or matrix rather, and we have to find A squared, you can see A squared simply means you multiply the matrix by itself. That is A times A. I know this is easy, but I will explain this also so as to, still freshen you up your memory of what I've taught you on the product multiplication. That is multiplication of matrices. And it's at the same time to explain further what I've just discussed under matrix multiplication. Now, this is what? Okay, let's split it so that we don't get confused. Let's split it. So this is normally what? This will now mean 4, 7, 5, 2 multiplied by what? 4, 7, 5, 2. Okay, that is what this one means. Because A squared. So the result will now be that place will not take it. Let us come down here. Let's come down here. Yes, let's come down there. Let's come down. So we have what? Now the first element here is 4 multiplied by 4 here. 4 times 4 plus the next element on that row is 7 multiplied by 5 here. 7 times 5. That is done. Now the next, we are done with 4 and 5 here. It remains 7 and 2. Beautiful. 4 times 7. 4 times 7 multiplied by 7 times 2. So you now add 7 times 2 there. You add 7 times 2. Okay? I hope that is clear. We are done with this particular, because it has only 2 columns. So, and the rows are complete also. So we are done with that. It now remains 5 and 2. Oh yeah. 5 by 2. Sorry, don't mind me. 5 times 4. 5 times 4 plus 2 times 5. Okay? Now it remains this column. 5 times 7 plus 2 times 2. So you can see. So the answer that will give you, so that we don't waste our time, you can draw it yourself. These are elementary things. So we're going to get 51, 42, okay, 31, 39. So that will be the result. That will be the result. That will be the result. Okay, I'm going to give you another exercise here, which we had to what I've given you before. Yes, I'm going to give you. Let me give you the exercise. So what you just need to do is, after doing the exercise, you screenshot it and send it to my what? To my email address. I'll give you the email address later. It is a must that you do it. It's an assignment, and it will hand you marks. Yes, that's the truth. That's the truth. So let's say that we are given, example, given that matrix A is equal to 1, 2, 3, 4, 5, 6, and matrix B is equal to, let's say, 7, 10, 8, 11, and 9, 12. 9, 12. Now, suppose we are asked to find AB here. You know, just like what we did for the other one. Let's say we are asked to find BA. Or should we check whether AB is equal to BA? Should we check whether AB is equal to BA? Oh, should we check so that we know? Okay. All right, let's check. Let's check AB. AB will be 1, 2, 3, 4, 5, 6. Okay. And what B will be what? B is already 7, 10, 8, 11, 9, 12. So let's check the multiplication, whether it is the same, whether A and B is the same as B and A, whether it is commutative. What it means, you want to check whether the matrices are commutative. Oh yeah, let's go. 1 times 7 plus 1 times 7 plus, you know, I pick one here now, times 7 plus 2 times 8 plus 2 times 8. So that is done for that. And I said 1 times 7 plus 2 times 8. Now plus 3 times 9. That is what? Plus 3 times 9. Sorry. Okay. Again, let me again. Don't let 1 times 7 plus 2 times 8 plus 3 times 9. That is the first multiplication. Will this place occupy this thing? Will it occupy it? Okay, let's come down a little here. Or okay, it will not. The bulb will not be. Now let's check it here. Let's check it here whether it will work here. Good. Now again, 1 times 7. 1 times 7 plus 2 times 8. 2 times 8 plus 3 times 9. That forms the first multiplication. That's the first location. Now the second one. Okay. 4 times 7. I hope you are following. Okay. Plus 5 times 8. 5 times 8 plus, you know, I said 4 times 7 plus 5 times 8 plus 6 times 9. I hope you understand. Oh, we have made a mistake. Wow. Don't mind me. We have made a mistake. We have not multiplied 10. Sorry. Sorry about that. You know, we have multiplied 1 by 7, 2 by 8, 3 by 9. Don't mind me. Now let's now pick, because the second column must be multiplied too. Sorry about that. Now 1 times 10 plus 2 times 11 plus, you know, I say 1 times 10, 2 times 11 plus 3 times 12. Good. Because each time, you see, when you multiply all the rows there, we multiply the column here. All the rows there, multiply the column here. So that was a blatant mistake. Sorry about that. Now 4 times 7, because 4 is in the second row, but first column. 4 times 7 plus 5 times 8 plus 5 times 8, then plus 6 times 9. 6 times 9. That is true. That is done. Now the next column. 4 times 10. 4 times 10 plus 5 times 11. 5 times 11 plus 6 times 12. 6 times 12. Okay? I hope you can carry out this addition. So carry out the addition by yourself. Okay. And let's want to check something. Let's do it then. Let's do it. Oh, want to check something. 7 plus 16. That's what? That's 23. 23 plus 27. That's 50. Okay. Now 10 plus 22. That's 32. 32 plus 36. That's 68. Abi? 32 plus 36. That will be 68. Okay. 4 times 7 is 24. I'm sorry, 28. 28 plus 40, that is 68. Okay. 68 now plus 54. 6 times 7 is 54. 6 times 7 is 54. That will be what? 122. Okay. So this one 122. Yes. Yes. Now 4 times 10, that's 40 plus 5 times 11. 40 plus 55. That's 95. 95 plus 72. 95 plus 72. 7, 16. That is 167. 167. So we obtained this for the product of A and B. That is when we started with A. So we get that. Now we want to start with B and see if the same result will be gotten. In mathematics, if I say 2 times 3, 2 times 3 is the same thing as 3 times 2. So we want to check whether it applies to matrices as well. So the first thing we're going to do now is we are going to write B. And our B as given is 7, 10. So we want to check BA now. We are checking what? We are checking BA. Okay. 7, 10. 8, 11, 9, 12. This is what we want to check. This is B. Now multiply by A. And our A is given as 1, 2, 3, 4, 5, 6. Is that true? Okay. Yes. Now let's multiply out. In fact, let's first of all check. Is this thing? How many? What's the order of this matrix? 1, 2, 3. The rows are 3. 3 by. Then the columns are 2. So 3 by 2. And this 1, 2. Now for the second one, what's the order? 1, 2. So that's the row. The row is 2. Column 1, 2, 3. Okay, so it's conformable because 2 will swallow 2 here, and we're getting what? 3 by 3. So it's conformable. Our result should be what? 3 by 3. Should it be 3 by 3? Let's check. Let's check. Okay, because the other time we tried to, okay, let's check, no problem. Let's check. Because in the other one, that's interesting. In the other multiplication, wow. The other multiplication, from here, you should have known that the answers are, the multiplication is not conformable. Because in AB, let's check here. AB has how many rows? 1, 2, 2 by 3, then multiply by, BA has many rows? 3 by 2. 3 by 2. Wow. Hey, now this will swallow this. It will be 3. This one will be 2 by 2 matrix. Because and the other one, BA, is 3 by 3. Automatically, they cannot be the same. But let's show it out. Since the others are not the same, they can never be the same. The same result cannot be gotten. Let's check. 7 times 1. 7 times 1 plus. Sorry about the network error. I've been receiving calls. Sorry about the network error. I've been receiving calls. Sorry, I'll make sure next time. Hello. Can we continue? Sorry about the calls. Shall we continue? Shall we continue? Sorry about the calls. Sorry about the calls. Sorry about the calls. You can't hear me. You can't hear me. I'm here. Can you hear me? The question is, can you hear me? Network problem. Oh, can you hear me now? Can you see the board? Okay, you can hear me. You can see the board. Sorry about the network break. Okay, thank you. So now we have done this 7 times 1 plus 10 times 4. This is it. Now let's move to the next one. 5. 7 times 2 plus 10 times 5 plus 10 times 5. Now we are done with the column here too. 7 times 3 plus 10 times 6 10 times 6. Okay, I hope that is taken. Shall we continue? Good. Can you hear me now? Can you hear me now? Can you hear me? Let's continue. Now, 8 times 1 plus 11 times 4. That is done. 8 times 2 plus 11 times 5. Now, 8 times 3 plus, say 8 times 3 plus 11 times 6. Now, 9 times 1 plus 12 times 4. 9 times 2 plus 12 times 5. 9 times 3 plus 12 times 6. Yes. That is that about that. So let's write the result out. Let's write the result here. Let's write the result here. The result is 7 plus 4 plus 40. That's 47. Hello, student. 64. 21 plus 60. 21 plus 60. 81. 8 plus 44. 52. 16 plus 15. 55. 16 plus 55. That's 71. Then 24 plus 66. That's okay. 9 plus 48. 57. 18 plus 55. 18 plus 60. That is what? That's 78. 27 plus 72. That's 99. So the result is this, which is different from what we obtained before. Okay, they're not equal. Maybe let us stop here because I have been consistently receiving calls. So maybe we'll continue later. I will announce to you when next we'll continue. So let's stop here. So we'll continue later. Now, the assignment I gave to you, do it and send it to my email. The email you are going to use is Dr. Ogunshola oj@gmail.com. So you're going to use that email. So thank you for your audience and your patience. God bless you all.